Hey, what's going on? It is Shav. Welcome to Coding with Shav. Sunday, April 10th, 2022. Yeah, we are we are having a very cold day today. Um, Something like in the 40s, which I guess it's expected for spring. And it's a Sunday, and at least it's sunny outside. So what can you do? Yeah, but not cold enough that it will prevent me from bringing you another coding problem today. So this is on my streak of doing a coding problem a day for ad infinitum, for until I'm an expert in everything algo related. And yeah, today I wandered into the daily challenge, which happens to be 682 baseball game. If you, by the way, before we begin, remember to like this video, subscribe. If you like my other videos, click on the link below to do that. And yeah, it'll help me a lot, help the channel a lot, and I appreciate your support. Comment if you have any feedback for me. I'd love to hear it. Okay, so this problem is called baseball game. Again, it's 682. It has more dislikes than likes, but I think this problem to me it's pretty straightforward. And Yeah, let's just go over the description first. You are keeping score for a baseball game with strange rules. The game consists of several rounds where the scores of past rounds may affect the future rounds' scores. At the beginning of the game, you start with an empty record. You're given a list of strings ops, where ops of I is the ith operation you must apply to the record and is one of the following. An integer x, record a new score of x. If that's the last value, then do that. Plus, if the last value is plus, record a new score that is the sum of the previous two scores is guaranteed. There will always be two previous scores. D, record a new score that is double the previous score is guaranteed. There will always be a previous score. C, invalidate the previous score, removing it from the record is guaranteed. There will always be a previous score, and return the sum of all the scores on the record. So, for instance, if you have your operations, which include the value, the operands, right? This ops array, you have 5 to C, D plus. So the answer was 30, and the explanation is, if I had 5 to the record is now 5. If I had 2, the record is now 2 and 5. So I'm pushing these on to the data structure. I'm using hint. Invalidate and remove the previous record. So if I invalidate, so that last number added, 2, will be taken off the data structure. And D, all right, will have what we'll do, if you get a D, you double the last score and add that to the record. So you double the last score. You don't remove the last score. You double it and add it to that resultant value to the record. And add 5 plus 10 equals 15 to the record. The record is now 5, 10, 15. So you take the last two scores. You don't remove them from the record. You take the last two scores and you sum them together and add their sum to the record, which will add another score to the record, increasing the record size by 1. And so at the end of the day, you sum all the values in the record and you get your final answer. Okay, so the interesting thing is here, this looks like a pretty straightforward problem, and I kept alluding to data structure, and for those of you who are doing computer science right now, that data structure should be a stack, right? And just to let you know, it doesn't have to be a stack. You don't actually need a stack to do this. You can do some you can do this through some string manipulation alone, but I thought just because this is like a learning video, we want to actually use a stack data structure to do this, because the order of operations of the stack, getting practice with that, is good for more complex problems down the road. All right, so basically you have your stack, which is representing your record. Okay, so what I want to do is I'm going to iterate through the operations. Okay, so this is me going through the initial input operations array. So now it's simple. It's as simple as just looking at each of the conditions, right? So what I start off doing, and if you have a similar problem to this later down the line, you can think of it like this. Make sure you enumerate your conditions. It's not always as simple as just enumerating the conditions, because of, actually I'll show you stuff, reasons why. Equals plus, and else. Okay, so let's look at the conditions. So this is for the condition C, which is invalidating the previous two scores. This is for the condition D, which is doubling the previous score and adding it to the array. And plus is for the condition of plus, which is taking the last two scores, summing them together, and adding that result to the array as a new score. Okay, and then finally, anything else, there's no operator that represents those, so that's just an operand, so we just push it onto the stack. So I'm going to write out the operations. So the first thing, how do we get rid of the last score? We just pop it off the stack. We're going to remember a stack is last in, first out. And this is important because expressions are evaluated in this manner typically, right? So if we have 5, which is the last in, then 2, now that's the new last in. If we pop again, right, then we get 2 because it's last in, first out. Okay, last in was 2. When I pop, which means remove from the stack, I get the last in, which was 2. And then I pop again, and then I get 5. Okay, so it's like, that's why they call it a stack. Stuff gets placed on top of the stack, and you pop stuff off the stack, like, you know, somebody's putting dishes, dirty dishes or something like that, right? Or a stack of dirty dishes, whatever. So then the next operation, remember, we also have a peek operation on a stack where we look at the top element without removing it off the stack. So remember what D does, it records a new score, which is double the previous score. Is guaranteed there will always be a previous score. So look at the previous score and then just simply push that value onto the stack. Okay, now plus is the trickiest of all, you know, relatively speaking. So what we have to do is take the previous two scores and then add their sum to the stack. Okay, so what we can do is we can remove the last two scores okay, and remember it's last in, first out, so in this case it would be 2 and then 5 would be removed out, or actually by this point we have 5 and 10, so 5 and 10 and 5 would be removed out in that order, very important. Then we record push. Now that I've removed these from the stack, I need to re-add them to the stack, okay? Because it doesn't say that these are invalidated, right? These are still removed. But the important thing is I need to maintain the order in which they were originally placed on the stack, okay? Because if I have 5, 10, 15, right? Okay, if I pop the last two elements off the stack, right? So if I pop, I'll get 15 and then 10. But if I add the elements back, if I like S1 equals 15, S2 equals 10. If we add in the wrong order, then the stack will become 5. Oh boy, Leetcode has, okay, 5, 15, 10, and that's not good because it does matter, because some of the operations, like for example the D operation, require you doubling the last score. So if you have to do a D here, then it becomes 20, whereas if we, for the original stack, if we did a D here, it would become 30. And remember, the sum, these two sums in the end of the day are different, because this sum will be summing a 30 in the final sum, whereas this would have only been summing a 20. So order of operations is tantamount to getting this right. So make sure, that's why I made sure to add S2 first and then S1 to maintain the stack order. And then record.push S1 plus S2. Then, okay, so we're pushing the sum on, which is the last element now added to the stack. Record.push. And now all we have left is parse int. We have adjust the operands themselves. So parse int, we turn it into an integer because my stack is of integers. And then, right, so while, okay, then finally we just sum the resulting stack and we return sum. So we sum all the values, so we pop every element off. So if we have 5, 2, or whatever it is here, by 5, 10, 15, right, then we pop off 15 plus 10 plus 5, right, and the stack is empty at that point. So let's see if this works. If op equals, gotta make sure I get that equals right. If record.push, okay, push, okay, and there you go. Let's run it. There you go. Okay. All right, so that's the solution that worked. Again, we could have made this more efficient by not even using a stack. We could have done string operations and just maintained a variable in the middle, which would have sped the whole thing up. But yeah, I just wanted to demonstrate the use of a stack. Okay, so if you like this video, please like, subscribe, etc. And I will see you next time for another coding video. Hasta la vista.